Hi, my name is Anish Agarwal, and I'm going to be a sophomore at UNC this year. I want to major in biochemistry, and the reason I want to be a mentor for Chemistry 261 is because I feel that the mentors are really important to my success in the course, and I had a really positive experience with them, and I want to be able to provide that and that level of assistance to students that are currently taking the course, as I feel it really made the learning curve more manageable and really helped me out.
To solve the following synthesis problem, first we have to look at the starting materials and the ending materials. And the difference that we can see is the addition of the hydroxyl groups at this carbon here and this carbon here. And the only way to add a hydroxyl group to two different carbons in the same synthesis problem is to proceed through an epoxide. So first we need to add a leaving group to the starting material. And the only way to do that is through a radical halogenation reaction. So we can use bromine and light to add a leaving group. So next we want to create an alkene. So we need an elimination reaction. So we could use a strong base and a good nucleophile to result in an E2 elimination reaction to form the most stable alkene, like this. So and now from here, we need to form an epoxide. So for an epoxidation reaction, we can use the epoxy acid CH3CO3H. Now we formed this epoxide. So now we need to add those two hydroxyl. We need to finish with those two hydroxyl groups on both of these carbons. And what we can notice is that the stereochemistry of the oxygen here is opposite of the hydroxyl group on the carbon here. So we should attack, in this case, the most substituted carbon with our nucleophile for this next reaction. So we can use an acidic substitution reaction here. So we can use H2SO4 as our acid catalyst, and we can use H2O as our nucleophile, because we want at the place of attack, we want a hydroxyl group to be added. So the water will cause that, and the leftover oxygen from the epoxide will be hydrogenated as a part of this reaction. And there we have completed the synthesis reaction from this molecule to this one over here.